myself Chiranjeev Sarkar, Vice Chair, Tunnel Association India Young Member Group. We welcome all of you in our today's webinar 40. In topic of sustainable design strategy for tunnels by Mr. Sanyal, founder and managing director of Bouw Consultant. About Mr. Sanyal, he is the founder and managing director of Bouw Consultant based in Gurgaon, Haryana. He is having more than 25-year experience in the transportation sector. His career, his academic career, highlighted mainly by graduated in civil engineering from Indian Institute of Engineering and Technology (IIST) Shibpur, accompanied by master degree in TAIym Engineering from prestigious University of Guards and Mountains. Mr. Sanyal's profile having a various vast sector of experience in railways, highways, in architectural marvels, covering Ahmedabad Metro, Mumbai Metro tunnel project, in Venial tunnel project, Jammu and Kashmir T10 railway project, Chennai Metro, Delhi Metro, Gurgaon Metro, Jammu Udhampur link, and the iconic London Underground and the blasting Kolkata Metro. So, Mr. Sanyal, it's over to you, sir. You can start your presentation. Thank you once again. So, our format is initially you will complete your presentation, then we will have some question answer session. Okay.
Okay.
So our session already recording already has been started. Yes, over to you, sir.
Yeah, thank you, Chiranjeev, for this introduction, and thanks all for attending this, joining this webinar. Because after a hectic day of work, you are still here to listen to me, and thanks a lot. Now I'll share my screen. Just let me know if it is visible.
Yeah, it's visible, sir. You can continue.
Okay. It's visible, right?
Yeah, it's visible. Sir, even if possible, you can also switch off your camera, maybe some. Yeah, then you can continue again. We can on camera again in the question answer session, sir.
Yeah, sure. Now, I'm here to briefly present some strategies for designing tunnel based on sustainability aspect. You know, as you know that a lot of things are happening around us with regards to sustainability, environmental aspect. When we talk about sustainability, it is not only about planting a tree. You know, it is more than that. Sustainability is it is more like if you define sustainability as per UN standards, then it was developed by Brundtland Commission, which says that the sustainability is all about meeting future. Hello, can you mute this? Yeah, I think my skin is visible, right? Hello. Hello.
Yes. Yes, sir.
Yes, sir. Now, sustainability. When you talk about sustainability, it defines by UN charter that it meets the future needs without compromising the future generation. So, what does actually this mean? It means that while we carry out our economic activity, we carry out other activity, developmental activity, we should take care of three aspects. Basically, it involves environmental, social equity, and economic demands. And if we draw these three circles, if you can see here, environment, society, and economy, there is an intersection which we can define as a sustainability. So when we develop any project, any aspect in anything, any work we carry out for development and other activity, we must take care of these three circle of environment, economy, and society. Uh, we should coexist, and we meet our future requirement about whatever is required. Like we need infrastructure, we need other kinds of, we need to extract mineral, we need to use energy, we need to use water, water resources. So the main purpose would be like we'll be using the resources in such a way that it does not hamper or it does not jeopardize the requirement of future generation. If we go in more, a little bit more in detail, we can say this sustainability is basically we have three pillars. One, as I already explained a little bit, is social. Second one is environmental, and third one is economics. So, what is social? Social it defines that the meeting needs in terms of health, education, housing, development, and etc. Environmental is all about preserving species, natural resources, and energy. And economics, creating wealth and improvement of living standards. Now, sustainability in construction. When we talk about a specific application of sustainability in construction, it involves like a lot of activity, right? We use for construction, we use energy, we use environmental resource, as I said, water. We use extract mineral, we use steel, we use consume cement, we use other kind of minerals. We use steel. Then in the process, we also produce waste. Also during the manufacturing process, even when during the construction stage. So and in this respect, we also need to have a planning, like how we are going to utilize this our resources to minimize the waste. That planning, that strategy is also part of sustainability. When you use water, like how much water, if you consider any tunnel project, like any construction project or tunnel project, especially when the water is coming out from tunnel, most of the cases, we see that the tunnels water are very like there, as you know, there is a two kind of water. One is groundwater, which is coming through waterproofing membrane and going out, draining out from tunnel, and second one is like your surface water, which is coming from road. So when we talk about surface water, that involves lot of oil, lot of other material which is not conducive for these water bodies when you are draining out to some of the water resources nearby. So we need to take care of that water. We need to properly treat that water so that it is not harmful to the species and other elements, other animals. When we are living, when we are just draining out the water to a particular source or particular river or particular any kind of a natural drain. When you talk about material, like sustainability in the material, like we can use innovative material, like we can replace steel, use of steel with the GIP, like polypropylene fiber or something similar kind of things. When you can in high tech material, we can reduce use of material. When you suppose in case of tunnel, if we do lining, we use concrete. Like in order to produce concrete, we generate a lot of greenhouse emission. We produce a lot of CO2. So our motto, like in from the design stage, should be such that we use optimal, or we try to use a minimum quantity, so that an innovative material, so that carbon emission can be reduced. When you talk about like other activities like climate adaptation, our design should be such that it does not hamper our environment. It should be it should like it should comply with the nature, that as far as possible the environmentally design, you know that is also part of sustainability in terms of construction. When you talk about procurement, in procurement, we need to have a proper plan strategy, how much material we need to procure and at what time, and we so that even like what kind of material we can reuse, like excavated soil, excavated rock, how much you can use in a brigade, how much you can use in a backfill. So all these things needs to be pre-planned so that we try to use local material. We can avoid transportation, and transportation creates a lot of greenhouse emission, a lot of CO2, a lot of pollution. So all this aspect is a part of sustainability in a construction. Now we are coming down to specific application in a tunnel, right? Tunnel is as you know, tunnel is a very extremely energy intensive process that can have significant site and cost bearing on a project and community. Traditionally, tunnel uses massive equipments and machinery and substantial consumption of material and natural resources. In a tunnel, like in in a tunnel or any construction project, we use maximum land can we use maximum material, we use maximum natural resources. It consumes, as in overall, you can see that construction consumes around 25 to 30% of energy we totally produce, and 40% of greenhouse emission is responsible generated from this construction activity. Now, impact of construction, there is some key points. If we go through this, what is the impact on construction and environment? We see major contributor to CO2 than any other industry. Around 40% of all global emission CO2 is from our construction industry. It consumes over 60% of extracted non-renewable resources. Over 50% of landfill waste is generated by our construction activity. Over 40% of water pollution is generated by our construction industry. Over 20% of air pollution is generated by construction. Now, therefore, there is no surprise that the major environmental impact of tunneling process include energy consumption, material and resources, and site disturbances. In the process of development of tunnel or any construction, it creates a lot of disturbances in around the like location where we do this kind of execute this kind of project. Even it disturbs local, like um, uh, what I say, like local people, they're earning. Sometimes you disturb their earning, resources and earning the way they live in a forest. Now, current scenario. If we talk about current scenario, how we are dealing with this kind of sustainability aspect in our design. At present, we can see that there are bits and parts we adopt in our project, such as uh, use of local material or excavated material we are now trying to use in place of disposing it off, or use of as a mark, or something like that. Or other than this, some of the things which we do, like we are not exactly that much we are doing, like we are using solar energy for tunnel construction and tunnel maintenance, and during the life cycle of the tunnel. Now, if you understand the like if we really wanted to develop a like a sustainable tunnel design, or like during its life cycle, uh, it involves various stages. It uses from extraction of raw material from the mines, then it transported to factories, then they produce cement, they produce steel, they produce rock bolts, they produce other mechanical electrical items, and again we transport it to construction site. Again, then construction, this depends on the methods, how we are going to execute the construction, what are the steps, what are the things, and exact planning is required. And then when the construction is completed, then it goes on maintenance and operation. When the when the structure is on use, then it comes under maintenance and operation. You know? That involves also a lot of energy, lot of lot of material needs to be replaced, or we need repair, rehabilitation, strengthening. Then it comes also in demolition. Like during the construction process, we demolish something. We need to develop a strategy how we are going to reuse that demolished material, uh, and then the waste removal. When you use the demolished material, like some parts, you cannot use 100% material. You cannot reuse that material. But we once you use certain part of the material, we then rest of the material you need to dispose of as a waste. So this total life cycle includes from extraction of material, extraction of raw material or ore from these mines, and then it goes up to tunnel demolition. All this aspect needs to be taken care of. It is not only about only construction stages, like we are going to get the steel, cement, and we are just constructing it. It is not about that. All the life cycle of the tunnel, from starting from extracting ore and disposal, it it should come into picture in a, if we want to really develop a sustainable tunnel design. uh, Now here's a simple graph. You can see tunnel life cycle cost, how it depends on the time. Like, if you see at the planning stage, if you do proper study and design, it has huge impact on uh, cost saving. If you can see the green line, when you invest in planning stage, when you invest in uh, investigation and proper design, proper study, the cost of operation stage is going down. And if you do not invest, do not do proper study at the beginning of the tunnel stage, like DPS stage or something like that, then the cost goes up. You do not have control over it. So it is always better that the DPR and other preliminary studies should be carried out very carefully, so that overall impact during this life of the tunnel going to reduce during the operation stage. Now, as I explained that life cycle cost, all the cost of the tunnel during its life cycle are construction cost of the tunnel structure and equipment of the tunnel, for the following up cost over the lifetime, maintenance, repair, operation cost. One significant parameter is the service life of each component. Like, see, we know that the concrete, we have we can achieve 100 years of life and more, even more. But for mechanical parts, electrical parts, we have very limited life. We have 20 years. So our planning must be such that the and replacement cost should be as far as optimal. How we can do that? I think we need to develop a monitoring strategy or maintenance planning, like maintenance or repair planning. We need to have periodic schedule inspection, like visual inspection, detail inspection. Visual inspection can be done in every month, or maybe every yearly twice. we can do more rigorous inspection in every 2 years, maybe every 5 years. We can do more detailed investigation. There are late guidelines are available internationally, so that we can plan it. We can plan the maintenance operation in such a way that we replace or we take action so that tunnel operation does not get disturbed or does not get hampered. Right? Suppose in a tunnel, when the life of a particular electromechanical equipment, or maybe suppose some lighting, some ventilation system, SCADA system need to be replaced. So we have like advanced information. If you know and if you do periodic like inspection, so you know when to repair and when to replace it. If you do not have any knowledge of what is happening there, so you will end up like because these equipments are not readily available, right? So you need to have a plan. You need to have a definitive plan so that you know which equipment at what time you need to replace, and when you need to raise a query, when you need to raise a purchase order, so that that equipment reaches the site at the right time. Otherwise you never know that certain electromechanical equipment stop working, and then you do not have any replacement for that, and you have to wait 2 3 months, so that your operation is hampered, right? Another, as I already said, that service life of tunnel is 100 or more years. It is always intended. So while service lives of equipments are significantly shorter, there's a demand of repeated replacement in the lifetime of overall cost. So if you see, sometimes what happens that the construction cost, civil construction cost I am talking about, uh, uh, it overpassed by this maintenance and replacement. If you consider 100 years of design life, 20 years is your electromechanical equipment service life, then you need to replace at least 5 times. So if you consider our electromechanical and other costs is 20%, so you can multiply 20 into 5. So it is going to catch up the construction cost of the tunnel. So we need to have a definitive plan. So as I said, sustainability is not about only planting trees. It is about overall planning. You need to have a maintenance planning. You need to have a planning for waste management. You need to have a planning for water treatment, water, like how we are going to deal with the drain water, how we are going to utilize maximum energy, how we are going to evaluate alternate energy like solar energy, and do you really need ventilation? That is one question I'm going to come a little bit later. Now we go to next slide. Now there is a very few basic tips you can say how we can do we can be more sustainable in our particular application to tunnel. Like excavated water reuse, you can reuse it, utilize the surface dust control. You can utilize it for surface dust control, or maybe aquifer recharge. Right. The mark use, it is always advisable that the local disposal transportation, like if you like you have lakhs of cubic meters of excavated rock or soil. If you want to dispose it off totally, then you need to transport it, right? And if for a tunnel like 5 kilometers, 10 kilometers, you need to every day you need to because we have one truck which can carry 10 15 tons of um, like it has capacity of 10 to 12 ton, right? So if you want to dispose of all these things, that trucks have to make a n numbers of trips. Okay, it will generate huge amount of emission. So it is always better that we have a beforehand planning that how much mark we can reuse either as a battery material or as an aggregate, or maybe fine aggregate or coarse aggregate, whatever maybe. We can use fly ash or slab, local byproducts used in concrete mix, because the cement we are using, slab is the byproduct, right? So another way to minimize this carbon emission is to use of precast segments. These are mostly used in metro tunnels, TBM tunnels, but still in like conventional NATM tunnel that can be done. And GFRP reinforcement and bolts over the steel. If you consider geography reinforcement and bolts, still not widely used in till now. We are using only in case of like temporary bolting, like face bolting or something, maybe temporary construction works. However, uh, this can be used a good solution for future uh, when the more detailed specification and guidelines comes in. If you check this one, open 1.5% of global carbon emissions attributed to steel river alone. So if we use GFRP reinforcement bars, it will reduce 43% compared to our steel bars. Now, another critical aspect is like, we if we go for a refurbished TBM, a TBM, one TBM weighs around 200 ton, but maybe 1,000 tons, not 200 tons, 1,000 tons. So if we can reuse, and then that will obviously going to give us more sustainable solution in terms of in case of current projects like refurbished TBM. What will help? It will help 65% greenhouse emission compared to new one, 80% electricity we can save, and 99% material consumption. In case of reuse, we can only change parts or maybe very small parts of consumables. We do not need to change total TBM. So TBM reuse is going to great way help our sustainability in case of big tunnel projects. But I should mention here that TBM, refurbished TBM, we might get some trouble where people say that sometimes it does not work properly. But compared to that, if it's maintained properly, I think it can be done and it can significantly reduce other CO2 emission, energy consumption, greenhouse effect. Now, another important thing in case of sustainability, as I repeatedly saying that sustainability is not about planting tree, not about only during the construction. It also about maintenance. Recent study says that in case of like if we have I have some data, but I can share it here. Some of the European or Austrian country, they require more money to maintain tunnels which have been constructed 30 years back than constructing a new one. Their major problem is like drainage. The old tunnels, the drainage system was not properly executed. It was very simple, but these drainage are getting choked, and once the drainage get choked, the water cannot pass on and the pressure develop. So it is structurally bad. It is other way, like it cannot drain the water properly, so you need the water pressure develops. So that there's a technical. Another one is like if you cannot drain it properly, so your drainage is choked. So obviously the tunnel will have water issues, right? So our drain must be proper. There should be two kind of drains. One is groundwater and the surface water. We cannot mix it. Most of the tunnel we consider these are mixed and there is no proper drainage system. This is one thing. Second thing, the sintering. Like if you know sintering, the drain will get choked with the formation of some kind of carbonates. So this needs to be properly cleaned. And here also I stress that we need to have a maintenance plan, and how we are going to do before we propose the drainage system. We need to have a plan that how we can actually monitor this drainage and make it clear so that no other issues come in the later stage during its service life. So that that point I think we need to very carefully design during the design stage. Uh, Another one thing, the reduction in use of concrete. As you know that now there is a possibility that normally in an ATM tunnel we neglect all the temporary support, temporary lining or rock bolts. We do not consider as a long-term effect. But with the application of sandwich waterproofing membrane, we can consider as a combined effect with the primary shot kit and lining. So if you consider both of these together, composite action along with the waterproof membrane, the thickness of this lining can be reduced, and primarily we can say that 30% reduction is possible. We have a lot of data for that. You can refer any kind of like uh, mm, um, the waterproofing membrane manufacturer specification is available there. You can have more detail on that, but we can definitely use a combined system. But here one point we have to we have to remember that it might not work for all kind of geology. In case of London, we see they are extensively using this kind of composite lining because they have clay and they do not have water issue. If we have water issue, this kind of composite section might not work, might not be that much of effective. So another one thing, use of natural air movement and piston effect for moving vehicle. If you see many tunnels, we do not actually need the tunnel ventilation system. If you think of tunnel ventilation system, like if you put jet fan and total ventilation system, you need to you need lot of energy during its lifetime, but if you really study and make the proper analysis that some of the tunnels which natural, as far as we should try to use natural ventilation so that uh, the requirement of forced ventilation, mechanical ventilation is very less. But this is possible, as I said, Queen Bay bi-directional tunnels is 3.24 kilometer tunnel, but it do not have any ventilation system, mechanical ventilation system. It used natural ventilation system. When only in rush hours, like in the peak hours, they use forced ventilation, like mechanical ventilation. The rest of the time, when the traffic is low, they stop ventilation system. It uses the natural system as a ventilation for ventilation purpose. So and determine the ventilation if required for smoke control or air quality. You might be knowing that the ventilation purpose is two. One is like in case of fire, we need to get out of smoke, and there is another aspect during the operation of the tunnel. We need to maintain air quality inside the tunnel. Like we have some parameters like how much is NO2, CO2, or oxygen level should be there. So there is a two purpose, but we need to specifically see and check what is the basic purpose of putting a ventilation. It is not always that टनल है तो उसको वेंटिलेशन देना पड़ेगा, है ना. टनल में एक्चुअल रिक्वायरमेंट है क्या, वो देखना बहुत जरूरी है. उसमें आपको देखना पड़ेगा कि खाली स्मोकिंग पर्पस के लिए है या एयर क्वालिटी मेंटेन के लिए भी है. अगर स्मोकिंग पर्पस के लिए है, द डिजाइन माइट नॉट बी दैट क्रिटिकल बिकॉज दैट विल बी रिक्वायर्ड ओनली इन केस ऑफ फायर. बट अगर आपको ये it is required for maintaining air quality, then you have to have a proper mechanical ventilation during its lifetime, like lifetime of the tunnel. Now another aspect that how to minimize the electricity energy consumption. So in tunnel during the maintenance period or operation period, the major power consumption comes from lighting, because lighting like importance of driver visibility and evacuation in case of energy. Right? So very simple tips is there. Lighting stage management, like when the like normally some of the apartments we use, like if you go the lights lit up, and then when you go away from the area, light automatically switch on. The same system can be used, or like adjusted to the level of traffic. That automation can be done at this stage. uh, we can use lead technology. As for example, 100% lead installation will save 25 to 20 to 25% of savings in energy consumption. Yes, and this is very interesting. When we talk about rail tunnel, most of the rail tunnels we see the single line, like single line broad gauge. So the section requirement in a study, it has been observed that if the section is less than 41 square meter, right? So drag force inside the tunnel is too big that the train requires more energy to pull it out. So any section which is less than 41, we should not go, because in the suppose, as I said, the tunnel is going to be operational for 100 years, and suppose you are proposing a section which is 39, 35, and which will increase your energy consumption. So we should have a section. We should not have a section which is less than 41 degree. It is technically proved. It has been. There are papers which can be supported uh, in as a proof of this. Another one thing, gradient should not be less than, should be less than 0.85, right? So that is also, because if we give more gradient, then train hauling power will be required will be more, like operational capacity efficiency will be reduced. So this is a typical case, I think, when we are doing our masters in the University of Gas, and they said that uh, in Austria there is one tunnel where they have estimated that there are some issues with the alignment, so they were putting some higher grade, but they have calculated that the requirement of energy during lifetime is too big, which is more than the cost of construction of tunnel. So they need to change the gradient and increase the length so that their operational cost come down. So this is also very critical point. Now there is a very interesting, as I cannot, but I can just show you these graphs. Cannot give more detail on this, but there has been study carried out in Europe that some of the tunnels which are in need of repair or refurbishment due to their some certain kind of law, but they have carried out some studies tunnels, number of tunnels which are more than 30 years old. So if you can see the rock bolt, the strength, the horizontal axis strength percentage and tensile strength of rock, and the dark red line is the new one, and other lines are different tunnels existing graph, which shows that there is not much, there is no deviation of strength of rock mass even after 30 years. Why I am saying this, I will explain to you later. This is one case of rock bolt. If you go next slide, and this is for membrane. The red dark one color, that is actually new membrane, and other one is different tunnels. Stress versus strain curve, which shows that there is also no reduction in strength of the membrane. And they have also carried out some kind of tensile strength trace for this UCS test for this tunnel lining. The location is the top and the side wall, and surprisingly, they say they have found that there is no reduction in strength of this lining. So this they have found for like not on single tunnel but number of tunnels in Europe, one of the countries. So this also shows that there is no change in or degradation in the tunnel lining even after 30 years. Actually, there is no you can say there is no as such stress, so it is intact. There is no significant stress on that. So I am saying that the purpose of this, that actually this will help us in the future to develop a sustainable solution. Like we may not need double lining, we can go for single lining. That will significantly reduce the cost of tunnel, especially in India. In India, if you see, there are a lot of discussion on this. No, we cannot do like the reimbursement is higher, or do we really need this kind of inner lining, like a final lining in a tunnel when it does not have it does not uh, carry any load, because inner lining and rock support system is strong enough to even after 30 years. So there it is. If you consider 30 years, it is not a permanent, temporary condition. Like we support measures we do, like rock bolts, primary shotcrete and everything, lattice radar. All is for temporary purpose, right? In order to during required during the construction. But in reality, all these things are quite strong enough to take all the load for lifetime. So this might uh, be a new way of doing a tunnel maybe in future. But for that, we need to have a like guidelines, regulations for that. Till now, I think it is under research. So at the end, why sustainability is important? When we talk about more than a third of all waste being generated by construction industry, it does not mean just the waste on construction site, but the whole life cycle of buildings, from raw material extraction to production, transportation, construction, operation, demolition, and waste management. So we are the like major contributor uh, to like this kind of disturbances to the society and environment. So construction industry must wake up to tackle these issues, because in our country we are going to have a fast development, and we should encourage, we should develop a strategy so that the resources can be optimally used without disturbing our uh, ecosystem, without disturbing our um, the design should be environment friendly, and also to like we cannot stop developing, right? We need development and fast development for our country. So for our economic needs or social needs, so we should have a we should adopt a methodology, and there are other like few things which can be like the thought of, like which I have to mention, as I said, uh, some of this is, it might look some theoretical, like geothermal energy. Sometimes in underground construction of tunnel, we found there's a heat in the underground. So the geothermal heat can be converted into energy that can be used. And like inclined tunneling, uphill, so gravity assistance in mark removal reduction. Like when you talk about tunnel excavation, we can plan it like that. The hill, when we develop like to removing the mark, we can excavate higher side of the tunnel, so that a natural gradient can be used to transport the mark, or hauling effort will be reduced. Like, and can also green power in terms of maybe like hydropower, and maybe solar. Though I could see that in recent development, all the tenders of NHI or NHID cell, they are proposing some kind of solar system. This is good. It's a welcome decision, but as a whole, uh, construction industry of a tunnelers, we are responsible for this kind of adopting this kind of solution. Thank you very much. Thank you.
Yeah, thank you, Sanjay, for this. You can on your camera also. Uh, Thank you, Sanjada, for this amazing presentation. I think it's cover all about A to Z about the sustainability in the tunneling, starting from material, design, construction aspect, each and every aspect. It's a nice presentation. So now forum is on for question answer. So you can ask your question by raising hands, or you can text here. So Sanjada, you can on your camera. Yeah. So there is first question. I think is any set of guideline or standard DS for sustainable tunneling. The first question is any set
Okay.
of guidelines or standards DS for sustainable tunneling.
I think we have guidelines, international guidelines. Just let me. Yes, we have guidelines for this. Uh, yes, we have guidelines, but I can share it later. We have guidelines. Yes.
Okay. The next about what about the preliminary works geotechnical investigation, for example. I think the question is not complete actually. What about the preliminary works geotechnical investigation, for example? I don't know. We could not get you, Mr. Harib. Yeah. The question is now, what about the preliminary works geotechnical investigation uh, impact on the sustainability?
Okay.
Yeah, means what about the
See,
preliminary works, geotechnical investigation that need to be done? What is impact on the sustainability?
yes. So I can straight away remember that when we talk about any tunnel projects in bidding stage, we see that there is a geotechnical baseline report, right? We have all the parameters like UCS, joint properties, and other things, but we do not have physical property check. If we do not have physical property check, then we cannot use it. Propose how much quantity is going to be used for aggregate, whether we can actually use those things in aggregate. Because now there is a clause in every tender that the mark should be reused either for a backfill or for a making concrete in aggregate, final course aggregate. But without knowing that, we can make a wild guess, right? We can say, okay, देख के तो हम बता नहीं सकते. We need to have some kind of like rock flakiness test, strength, other things, test, which is required to actually decide whether it can be used as a aggregate, right? That test I think we need to do in case of sustainability. Another thing, water. How much water is going to come? Presence of water, geothermal, like whether yeah, that is I think
Sanjada,
all
I
the
think you can.
yes.
Uh, okay. Sanjada, I think you can switch off your camera. Maybe some network internet
Okay.
quality is, yeah. I think then it will be properly audible. Yeah. So I think we have any other questions? The forum. I think there is no further
Yes,
question.
Mr.
So
Raj, I think.
yeah. Hello. Yeah. Now we are at the closing stage. So thank you all for attending our session. So this recording version of this session also will be available in our YouTube channel very soon. Also, all our previous webinars are already available in our YouTube channel. Kindly visit us in our YouTube channel. And again, we will thank you, Mr. Sanjay Sanyal sir, for his valuable time and his amazing presentation. We'll connect you once again in the coming futures. And thank you all for attending this webinar.